Hello everyone, here is the solution for problem 2 in homework 11. It is suggested that the following function of v, fv, the first one, fv is equal to the exponential of negative of absolute value of v. The second one, fv is equal to sine square v over v square, and the function c fv is equal to 1 if v is smaller than alpha and 0 if v is bigger than alpha. So this three function may represent an autocorrelation function of a WSS process or a spectral density function by setting v equals omega. So we want to know that which functions may represent either or both. So firstly, we would like to introduce these two theorem, these two property for the autocorrelation and the spectrum. So firstly, the property for autocorrelation are tall. So firstly, it is real and even if xt is WSS. Secondly, the Fourier transformation should be non-negative. So secondly, we want to introduce the property for the spectrum, for the power spectrum as omega. So if xt is WSS, then S omega should be non-negative. We are going to analyze these three functions. For function A, we want to analyze whether it represents an autocorrelation function. So firstly, we know that fv is real and even, and r tau is equal to E negative the absolute value of v, and it is smaller than the absolute value of 0. Secondly, the Fourier transformation for e to the power of negative the absolute value of v is 2 alpha over alpha square plus omega square. Obviously, it is non-negative. Then we are going to test whether it can represent a spectral density. So we can see that the Fourier, the exponential must be bigger than 0. So of course, SW is non-negative. So we can draw the conclusion that function A can be the autocorrelation and the spectrum. Then we come to the function B. So firstly, it is absolute real and even. So secondly, also what's more, is smaller than the limit of tau to infinity, sine square tau and tau square So this is R tau. So and equal to 1, and it is R0. Secondly, the Fourier transformation for this function is like this. So of course it is non-negative. Then we know that this can be an autocorrelation. Secondly, we are going to look at the spectrum. So it may represent a power spectrum. So because f omega equal to the square of sine omega of omega squared, and it is absolutely bigger than 0. So by the probability for the spectrum density, it can be a spectral density of a WSS process. Then we are going to move on to the last problem. So what if fv is equal to 1 when v is smaller than alpha and 0 when v is bigger than alpha? So firstly, this is real and this is even, and R tau is smaller than R0, and because R0 is 1. So but then we move on to the Fourier transform. The Fourier transform for branded should be 2 sine alpha omega over omega. So however, this might be negative. So the Fourier transform is not always positive, so that this cannot be an autocorrelation for WSS process. Then we move on to the spectrum. So because f omega is smaller than 1 and bigger than 0, the value of the function is always positive. Therefore, this might be a spectrum of a WSS process. So in conclusion, we solved this problem using the property for the autocorrelation and the property for the spectrum, and tested each condition holds or not. If it holds, we say that it is correct. If it is not, we say that it is wrong.